We'll give it a second for everyone to go ahead and join on in, and then we can get it started. All right, so let's go ahead and get started. So last class, before we finished up, again we were doing some work with this. So I'm actually gonna go ahead and clear this. This is from our last CodeWars kata that we were working on. But last class, I asked you guys to take a look at something called list comprehensions. And if you remember, when we were on CodeWars, a lot of the time we saw a lot of simple solutions that made use of list comprehensions to do stuff within just one line. And also, do excuse the little gray thing. I'm just testing out some new features here. But list comprehensions are those things that allow us to simplify entire for loops into just one line. So I'll start you guys off with an example. So if we have a for I in range 1 to 10, right? Again, we're going to print that I out. I run this. I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty straightforward. Now, if I wanted to save this to a list, so let's say we have, we'll just call this empty list, right? Just like that. If I wanted to take these elements in my for loop and add them to my list, well, I would just say empty list dot append I, right? If I go ahead and print out empty list, you see I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's look at the sort of general structure of this for loop, of this entire operation going on right here. So the first thing I want to do is create an empty list where the elements will get saved, right? All of my I values that are being generated in my for loop are being pushed into this empty list. So now we're going to basically create a for loop that iterates over the numbers 1 to 9, right? Because again, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're just going to add that item to our empty list, or to our item holder list, right? And then we're just going to go ahead and print out the list. And while that's happening, just give me a second. I'm going to go ahead and turn off the feature that's showing all the extra stuff. Okay. I'll actually go ahead and refresh, and I think that I might have turned it off. It was getting a little distracting. It's better for when you're just working alone, but for a lesson, it's nicer to just not have that in the way. So yeah, as I was saying, we then just go ahead and print out that list. So I'm going to show you the list comprehension equivalent of what I've just done, and then we'll be able to sort of compare them back and forth. So what we'll do is we'll say new list is equal to I for I in range 1 to 10. Okay? And gosh, this is distracting. Okay, there we go. And then I'm going to go ahead and print out new list. On this, you'll notice we get the same exact output. So let's sort of compare these two structures, see what's different, see what's similar, see how they might translate over into a list comprehension. So the first thing that we can sort of draw a similarity to is this range function, right? And we already know that the range function yields a set of numbers that a list can traverse over. So that's pretty straightforward what that's doing. But then when you see the for I in range, right, that's this entire part right here. So for I in range, and then we have an I right here. So basically this I by itself is very similar to this. I'm telling Python, hey, add this I component for every I that is in my range function. So again, you'll note that these are all 1 to 9. If I put a times 2 here and a times 2 here, we should see that every value has been multiplied by 2. And that's exactly what happened for both instances. So this sort of clause of my list comprehension is this clause of my for loop. And then the part where you actually add it, what you add is this item right here. And again, this is surrounded by our list brackets, if you will. And that's sort of just like this empty list part that I showed you guys from there. So again, a very simple usage, or sorry, a setup for a list comprehension. And as we move into our CodeWars kata for today, I'll show you guys how a list comprehension might make more sense. So with that little mini lesson out of the way, let's transition over to CodeWars. Let's see if we can find something we've done before. And if we can, no, that wasn't a good one. Here, let's do a level 7. Can I not sort by, okay, there we go. Popularity. And then we'll do difficulty, we'll put 7. So they changed the sorting a little bit. Okay. Let's see if we can find something. What's this? Square every digit. No, we did this one already. Trying to think of something where we can just go through it. Let's try this. Let's actually do the complementary DNA one and try this again. So let's train on this again. I think it won't show us our old, oh, there we go, our past solution. So let's try to use this as a sort of starting off point to guide us in how we can use a list comprehension. Again, general structure right here, so pause it if you need to copy that down or whatnot. So let's just remember this. This is best used when we're replacing simple for loops like this. Where do we have a simple for loop? Well, right here. So again, I'm going to bring this into our REPL because I prefer coding in there to CodeWars. So I'm going to comment all this out. And what we're going to do is let's just indent this down. There we go. Okay. So we know DNA. Let's just use this as our sample case. So this is going to be our test case, this string. And we should hope to get TTACG. Again, you can take a look at the prompt right here if you need some clarification on what we're trying to accomplish with this. But basically, if I print out the complementary strand, we get TAACG. That's what we get, right? You need all of this to accomplish that. Let's see if there's a better way to do it. Again, looking between my list comprehension example and what I'm working with my current solution, I think the quickest thing that we can cut down on is this for loop right here. Okay? So in this for loop, I'm iterating for every base. Actually, let's create a general sort of list comprehension structure. Okay? We know that this clause right here is the first clause in our list comprehension, right? For I in range, it's always similar to that. So we can start off with for base and DNA, and that's our starting off point. Now, what are we adding to our list? We want to have the base. So if I do this, base for base and DNA, and I print this out, this gives me A, T, T, G, C, okay? So I'm getting all of the components by themselves. Now what I need to go through is find their complementary pair. And I can do that by using the pairs dictionary that I already have. So again, we added on this pairs base. So if I do that, pairs base, right? This is what's getting added into my list. Now I should get a list that's TAACG, right? So now all I have to do is these are all independent elements in a list. If I want to combine them into a string, our .join string method might be the solution. So if I do boom, boom, right, because we don't want any spaces between them, .join, and I give it this list that's being created by this list comprehension, I get TAACG. And I can go ahead and actually cut this entire part out of my code. And it runs just fine. So really amazing what we've been able to do with our list comprehensions. We've been able to basically just condense, I think it was 3 to 4 lines to just one. So again, we've already done this one before, so I'm going to go over it pretty quickly. So I'm going to copy this back into our kata so we can train on it. So we have the pairs. Again, this can be given to us. And we don't have to really save this entire expression to a variable because it's going to get returned anyway. So I have that there. I'm going to go ahead and test it out. I pass all my test cases. Perfect. I'm going to attempt it. I passed all my attempt cases. So again, I'm going to go ahead and submit, and the submit button's right down here on my screen. My little camera box is covering it. So ignoring these solutions, you could see we basically did what the other solution did. So let's take a look at this. So we have the pairs as a dictionary, right? Pretty straightforward. We just formatted ours a little nicer. They're saying pairs for base and DNA. This one's saying pairs X for X and DNA. So they're just given different sort of placeholder variable names to each of the items. And then they've joined it. So yeah, pretty straightforward. So now let's head back and find another kata. Again, I'm not going to look for ones that necessarily focus on list comprehensions, but now that we have that under our belt, we've gotten a little bit of practice with it. I think it's time for us to keep cracking down on those 6 KYUs that we started working on earlier. So there it is, difficulty. I think they changed like the sorting thing. So let that load. Let's see this. Find the odd integer. Given an array of integers, find the one that appears an odd number of times. There will always be only one integer that appears an odd number of times. Okay. So we're given our example. So let's take a look at this. If we have an array, or sorry, in a list that just has the number 7 in it, we return 7 because it only occurs one time. 0 only occurs one time. That's odd. Okay. So in a situation like this where we have multiple numbers, so we have 1 appearing 2 times, but 2 only appearing 1 time. And that 1 is odd, so we return 2. Pretty straightforward. Let's go ahead and train on this. Now again, given what I have to work with, let's go ahead and just take a look back at our sort of reference of tools. These are all functions and methods and whatnot that we know how to use. So I'll give you guys a second, people watching the recording or whatnot. I'll give you guys a second to just take a look at this and try to come up with some ideas, pause it, see if you can think of anything that might help out. And I'll do the same thing. I'm just going to look at this one more time. Okay. Now, what I want to try out before I attempt this is, we know that this .count string method is a string method. So I'm just actually going to have an array real quickly. And I'm going to, is r.count 1, is that a thing? Yes, it is. So if I have another 1 in here, cool. So we know that our .count also works as a list method. That's pretty helpful. So now that we have that, or now that I know that at least, I'm going to go ahead and try cracking down on this problem. Let me make it a little bit bigger so it's easier to see. So I have a sequence of numbers, okay? I need to go through each item, right, each number, and again, I'll do this in REPL instead. So let's create a test case. Let's just have 1, 1, 1, 1, right? We'll have that 4 times, and then we'll have 2. Interesting. That was weird. So what we're going to do is, again, if I go through 4 item or 4 number in R, and I print out r.count that number, you see this 4 times, 4 times, 4 times, 4 times, 1 time, right? Because again, I'm basically counting, oh, how many times is this 1 in the list? How many times is this 1 in the list? How many times is this 1 in the list? How many times is this 1 in this list? And again, it's 4 times. That doesn't really change. But then when I come to this 2, how many times is the 2 in the list? 1 time. So I'm trying to think, and I think the best thing to do would be to use two functions, a self-made function, and then we're going to use another function called the filter function. Now, what I'm going to do before I go ahead and talk about the filter function, which is very similar to this map function, is I'm going to generate a function, again, a user-made function that's just going to say is odd count, right? The number of times that it's there, it's an odd number. Actually, try to think, is that the best way to do that? Huh. One second. Let's see. Okay. Yeah, okay. So what I'm going to do is we're going to have a function called isOdd, just isOdd. It'll take a number, and what it'll do is if, actually, that's not the best way to do it. That's definitely not the best way to do it. One second, let me just check something. Okay, yeah, okay. So I'm going to create a isOdd count function. And again, this function is going to tell me if a number appears in a iterable an odd number of times. So I'm going to have the iterable as an argument, and then I'm going to have the number as another argument. And basically, I'm basically just going to return the iterable dot count of that number, and if it is an odd number, if I do the modulus of 2 and return 1, then that should be something that appears an odd number of times. So here's what I mean by that. I'm going to print the is odd count. My iterable is going to be r, right? And I'm going to look for the number 1. And this should give us false. Yeah, because 1 appears 4 times. If I give it 2, it should return true, because 2 appears 1 time, which is an odd number. So that's that. Now I'm going to show you guys a function called the filter function. Filter function, yeah. Now what this function allows you to do is basically remove items that you don't need given a function that returns true or false. So again, I have this user-defined function that returns either true or false. Again, if you remember with our map function, I'm sort of applying this function to each item in my list. But with this, instead of changing the item, it wants to see if that item returns true, then we'll keep it. If it returns false, then we want to get rid of it. Okay? So I'm going to say, and again, I'll explain it once I've sort of gone ahead and coded it out. We'll just say x, again, just arbitrary name, is equal to filter lambda x is odd count never mind. This is not going to work now that I think about it. Actually, it will work. I will have to see. And then I want to give it r. Let's see what this gives us. Print x. Give me a filter object. So list. Let me clear this out from underneath. Okay, perfect. So what did I do here? Well, this is sort of like the part that gets applied to each item to see if it is valid. And this right here is the iterable. So basically, what I'm asking Python to do is, let me just change this to y instead of x. And let's see if that works. Okay. So what I'm telling Python to do is I want you to go through each item in my list R, right? In that item, okay, in that list, I want you to take this item and give it the variable x, okay? Give it the variable x. And then pass it on to this isCount variable. Again, R is my iterable. X is now that variable for the number. Now it's been passed in here. And this will return true or false. If it returns true, this x will stay in the list. If it returns false, then the x will not stay in the list. So if we go through this example by example, and again, I can add a 3 in here, and this 3 should also stay because it's in there once. So again, every item in R, so I'm going to start with this 1. This 1 is now an x, and it's been passed into my isCount variable. Well, in this iterable R, right, that's going to be my iterable argument. If I give it a 1 is there 4 times. So if you divide it by 2, you have a remainder of 0, not 1. So all of these are invalidated, and they get removed from the list. So then I'm just left with the 3 or the 2. So pretty awesome how we can just filter out items that we don't necessarily want. So if I take this and bring it into our CodeWars kata right here. And again, I'll cut this part out, paste it right here. That's our helper function. And again, I'll get rid of this, tab this in. Okay. So again, R is going to be our sequence, right? That's this right here, and sequence right here. Now what we're going to do is, since it's only going to be one item, if we take our list and we just return the item at index 0, because again, remember, if I got rid of this 3, because again, we can only have one item that gets returned. If I just return the item at the 0th index, at the first index, that's the item that I want to return. So if I go ahead and do this and test it out, there we go. All of our test cases are working out just fine. And if I go ahead and attempt it now, same thing. All of the attempt cases are working out just fine. And we can go ahead and submit. So now let's go ahead and check to see. Oh, this is good. This is actually good. People made use of list comprehensions, where they sort of did the same thing, where they just filter it out. Yeah, people just kept going until they got the item, and then they would return that item. So pretty nice solutions, actually. You can take a look at those if you're interested. So that's another 6K YU down. Let's look at the most popular ones again. Let's find something else to train on. What's this? This is strings. This should be interesting. Write a function that takes in a string of one or more words and returns the same strings, but with all 5 or more letters reversed. Okay. Strings passed in will only consist of letters and spaces. Spaces will be included only when more than one word is present. So what they're doing is they're taking every word in a string, right? And if this word has a length that is 5 or greater, then we're going to make it reverse. Interesting. I like this. Okay, let's train on this one. Again, let's start off with a simple test case. So we're given our sentence, right? Just like this. The first thing we want to do is split the sentence into parts. And that's not a function we've talked about yet, so let's go ahead and do that. I'm going to show you guys the actually, have I really not? .split function, string method, sorry. So if I have a test string, hi, my name is Varun, and I am streaming, right? Pretty straightforward. I guess I'm also a Python programmer. If I print test string .split, I get a list where all of the, where basically I've taken my string and on every space, I've cut it and put it into a list. So if I had something like this now, where everything was split by underscores, like that, I could also put .split and split on the underscores instead of spaces. Again, same deal. But if I make this spaces instead, you just get one big list because there's no spaces in here to split upon. So with that in mind, actually, we can just use this as our example. With that in mind, we can call this sort of like test string parts, right? We've just gotten all the individual word parts of our test string. So then test string dot split. So again, if I print test string parts, I get, hi, my name is Varun, and I am, streaming. There you go. So Again, this is a list, so it's totally iterable and whatever. And what we need to do is for every word that's greater than a length 5, we need to flip it. So I'm going to have a final, let's call this final. Again, it'll be an empty list. We'll remove all of our parts as we process them. So we'll say for part in test string parts. Right? We're going to go through all of these words one at a time. If the length of my part is greater than or equal to 5, right? 5 or more letters reversed. Then in order to reverse it, you can use our index notation. We can just say final.append part, boom, boom, -1, and that should reverse it. Else, final.append just the normal part. So again, if I come down and I print final, I run this. Hi, my name is, okay, so now that Varun, that's 5 letters, it's now gotten flipped, and I am streaming, and streaming is a lot more than 5 letters. So that also got flipped, but everything else stayed intact. And again, if we want to put this together, we already have our dot join. But now, what I actually want to do before we go ahead and submit this, because we've basically figured the whole thing out, is I want to see if maybe we can apply our list comprehensions to this. And again, this is a lot more complicated of a for loop, but I think it's still worth being able to compare the two between them. So excuse me, this is the part that we're hoping to make smaller, I guess. So again, let's start with what we know. If I wanted to just print out every part in my test string parts, I would just say part for part in test string parts, right? That's just this clause right here, and I'm just printing out the part with nothing done to it. Print that out. That's just what we already have, right? Now, we want to say we only want the part if, actually, let's put this in a better way. Let me put the palindrome. So let me put like the reverse version for all of them, right? Now we only want this reverse version if the length of the part is greater than or equal to 5, right? So we only want this part if the length of part is greater than or equal to 5. Oops. We also have to have an else. So actually, else part. And I'll explain everything, but just bear with me here. And just like that, we've basically just gone ahead and done the whole thing here. So let's compare this, because this is kind of long. These are the different parts, and I'll break it up for you guys. Oops. So this is sort of a backward structure, if you will. So again, we know what this does, right? For part, right? Now it's going to say, for every part in my test string parts, I want you to give me the backwards version, the reverse version, only if it is longer than 5. Otherwise, right, else, just give me the normal part. That's basically what that reads as. And I can actually go ahead and basically get rid of this whole thing and get this output. And we can actually shorten up our code even more. Again, test string parts is just a placeholder variable. It's really just test string dot split. I can put that in there and get rid of this as well. Run this. And again, we've condensed everything almost into just one line. This was, okay, so we had test string, that was one line. We have the for part, that's another line. We have the else, that's 2 lines, and then we have the if, that's 2 lines. So that's like 6 or 7 lines that we just cut down to 1. So again, for every part in test string.split, right, that's going to make this into a list. Give me the reverse version if it's less than 5. Otherwise, give me just the normal version. And again, you have to have this if-else for this part. Pretty awesome what we did here. So let me copy this. We'll bring it into our CodeWars coding environment. And what we'll go ahead and do is we'll say return. Again, it's not test string, it's sentence. So we'll just return. And we should put a dot join on it to put it back as a string. So pretty long. Again, it's not the most readable thing. Let's be honest. And oops. Oh, we need to put a space between them to join them. Hardly the most readable thing ever. This is a lot of stuff chained together. But that wasn't really my intention with this one. I really just wanted to show you guys how we're able to use our list comprehensions and put if-else logic in there, which is pretty awesome. And we have solved all of our cases. So I'll go ahead and submit. And I'm betting you guys that we'll see a lot of similar answers to ours this time. Because I definitely think, yeah, almost the same thing, basically. Just different variable names. So this guy made use of different list comprehensions. But again, for the most part, people did the same thing as us. Pretty cool. So yeah, CodeWars, really the cheat with CodeWars is just knowing these functions and knowing list comprehensions. Those are like the best things that you can do with CodeWars. They really get you good with learning how to craft those sort of things. So let's keep working. Let's do a couple more. We'll go for, we still have 24-ish minutes. So again, difficulty 6KYU. Let's try this. Sum of digits, digital root. Digital root is a recursive. This one does not seem fun. I do not want to do recursion. Who likes it? It's interesting. You probably know the like system from Facebook and other pages. People can like blog posts, pictures, or other items. We want to create the text that should be displayed next to such an item. This one does not seem interesting. Create phone number. This one seems simple enough. This is just like using indices. Again, we're going to get passed in a list of 1, 2, 3, 4, 5, 6, 10 items, and we'll just basically just format it into these, into a string. So this is going to be pretty straightforward. We can make use of an F string. Again, these are the brackets where the first 3 numbers will go. So that's going to be 0, 1, 2. So I'll put that up to 3. And then we have, let's see, 0, 1, 2, 3, 4, 5. That's going to be from 3. Jesus. 0, 1, 2. I'm counting the indices, by the way. Oh, and I don't think you guys can see that because it's down here in this corner. Oops. I wonder if I can move this to the side. Basically, you see this list. I'm just counting these indices and just cutting them into parts. We can bring this into our CodeWars REPL as well, actually. So let me copy this test case. And this was such a satisfying bit of code, actually. But yeah, we have our test number here. We'll just call this R or E. I want to format this so it looks like 1, 2, 3, 4, 5, 6. I think there's a dash. Yeah. There's a dash, and then it's 7, 8, 9, 0. That's what you want to format this into as a string. So the first thing we want to do is just print out all the parts and get those down separately. if I do E and I want to print out this 1, 2, 3, right? So that's 0, 1. So 0 is our start, and what's our stop? 0, 1, 2. 2 is our stop, so we put a 3 there. Up to but not including. Cool. Next part. Where are we starting from? 0, 1, 2, 3. We're starting from 3. Up to but not including. So 0, 1, 2, 3, 4, 5. So we want to go up to 5, so we're going to put 6 here. So 1, 2, 3, 4, 5, 6. Those are all separate parts. And then what we can do is we can just print 6 to the end. So if we're doing up to the end, we don't have to put in anything in there. And again, we can do the same thing with the 0. We can get rid of that. So these are all of our parts. And again, if I wrap this in a dot join, turns it into a nice, extra parentheses there. Never mind. There we go. Sequence item 0. Oh, it's because these are numbers, not strings. Oops. In that case, let's see. Yeah, these are given as numbers. So the first thing we have to do is turn them all into strings in order to make it look nice. So what I can do is, again, we have them as strings, and we want to make them into as integers, separate integers. Let's put it into a big string. We can just say R is equal to map. We're going to map the str function to E. Make that a list. And now when I print R, you get this, right? It's a bunch of strings. And honestly, in order to make it easier, I can just dot join the whole thing from the get-go. Oops. That should just go here. Like that. And there we go. A whole big string makes it easier. Now, I think we can actually get rid of this list. Let's try that. Does that work? Yeah. Okay. So boom. This is something we can use. So let's actually copy these two chunks of code right here. So this will turn everything that are given into this one big string. And then it should be pretty straightforward to format it. We'll use an F string. Again, the first set of numbers are in brackets, and then the next set are in dashes. So copy this. We'll put the brackets in here. Boom. Copy this. The brackets in here. And then we'll copy this and put the brackets in here. When we do that, run our test case. E is not defined. Oh, that should be, we'll just change this then. E. Ta-da! Pretty straightforward. Go for the attempt. You can go for the submit now. And again, what did we do here? Let's take a look at that. Ooh, this is a good one. This is a good one. This is something we haven't talked about. But this is really, really good. But basically, we did something very similar to this, where it's easiest to cut up a whole big string into parts like we're doing right here. So we take the whole thing, we put it as a string, because again, we're given just integers, and we just put it into one big string. And we just cut the parts and format it into our general structure. And again, that's something that they did right here. You can see that we're using the same indices, and then they just format them in. Pretty nice. But this is good. This is a whole unpacking thing. And we'll talk a little bit about that maybe later on. So cool. That was a fun one. I always like the string ones more than like the mathematical ones because they're so boring. Do a 6. I think we're close to leveling up, actually. Let's take a look. Yeah, we are really close to leveling up. So let's maybe we only need like a couple more 6KYUs. To look at persistent bugger. That sounds interesting. Write a function persistence that takes in a positive parameter number and returns its which is the number of times you multiply the digits in num until you return. Yeah, okay, never mind. I told you I'm not a fan of the whole like thing with math. In this kata, you're required to, given a string, replace every letter with its position in the alphabet. If anything in the letter isn't a letter, if anything in the text isn't a letter, ignore it and don't return it. Okay. This should be interesting. Let's try it. So the sun sets at 12 o'clock. That should give us 28, 5, 18. So let's look at, so if we look at E, right? A, B, C, D, E. That's the fifth one. H, A, B, C, D, E, F, G, H. That's the eighth. Okay. And they're all just separated by one space. And again, we're ignoring the spaces. And we're ignoring all of these like periods and punctuation and whatnot. So let's come on here to our REPL. Let me bring this in as our example string. Example. Okay. Now, the best way to know where an alphabetical item is to have an alphabet to reference, if that makes sense. So I'm actually going to import a library called import string, okay? And then I'm going to print string.ascii lowercase. If I do that, there we go. We get our whole alphabet to work with, just to help us out. And actually, we'll say from string import ASCII lowercase. And that should help us out. Again, you'll notice that this is all in lowercase. So the first thing I want to do is if I want to check where the T is, I can't do that, right? So again, the best thing to do is to make this lowercase as we go ahead and start off. I print out example. Again, this is our .lower string method. Everything's lowercase. Perfect. So what I'm going to go ahead and do is I'm going to show you guys the .find method. And we're going to look for actually, I'm trying to think of the best way to do this. Oh, yeah. In my ASCII lowercase, right? Lowercase. I want to find the index with level, the letter T is. So again, if I print ASCII lowercase, I get this whole string. And again, I know that the T, right, is the 20th letter in the alphabet. And this .find gives me the index of the T. And again, these are all unique, so all the indices are different. And I get 19 when I do that. So I can .find the index, and then if I add 1, then I get the item's place in the alphabet. So again, if I do that with E, which we know is 5, 5. If we do H, which is 8, we get 8. So this is what we're using to help us find where everything is in a in the alphabet. So what we can do is let's create a general structure, and then we'll convert it into a list comprehension to make our lives a lot easier. So we'll have an empty list. We'll just call this output or whatever. Say 4-letter in example .lower. Let's Again, we won't be able to manipulate it directly. Print letter. Let's just make sure we know what we're working with. And I'll comment this out. Shift. Oops. There we go. I print letter. I get all the letters in my thing, but I'm also getting all of these characters, which I don't want. So the first thing I want to do is actually get rid of all that. I want to say if letter is alpha, print letter. You notice when I run this, we'll lose all the spaces, we'll lose the comma and the period. So these are all the true letters. So what is this? This is alpha string, alpha string method. What this does is it just returns true or false if a string is alphabetical. That's it. So if it's an alphabet, it's valid. Otherwise, it's going to return false. So we're going to print out that letter. And basically, instead of just printing out this letter, we can just copy this chunk of code right here. ASCII.find, ASCII lowercase.find the letter, and then add 1 to it. If we do that, boom, we get the whole thing. We can actually do output.append. Then we can come down here and print output. There we go, 28, 5. And again, they want to return this as a string. So what we can actually do is instead of appending this whole integer thing, we can actually convert that into a string. Now I have a bunch of strings that I can boom, boom, with a space, join together. If I run this now, I get something very similar to the desired output, right? Which is what we want. Now let's actually go ahead and try to condense this. So I'm going to have, we'll call this output again, because again, we're just going to convert everything to this. And we'll start with what we have. Reset to mine. There we go. I don't know. REPL's being a little interesting today. We'll say letter for letter in example dot lower. Right? That's just going to give us every letter in there. Now, we only want those letters if they're alphabetical. You might be asking, why is my if statement now moving from the introduction to the end? The case of that is, again, if I run this, oops, if letter dot is alpha. Oh. The reason why the sort of checker to see if it's alphabetical has moved from here to here is that when I had it here, I could return either two things. I could either return the reverse portion or I could return the normal thing. So because I had that option, it went here. It's only going here now because I just want to filter out indiscriminately anything that isn't an alphabetical letter, because I don't have an else. You know, there's nothing else I can get returned except for this, if that makes sense. So again, we're just going to replace this chunk now with this. That's basically it. We then run this, we get our output. So I can copy this into our code. What I have to do now is just replace all of the names. So we just make this text.lower. And then we can just return our output joined together. Join output. Test this out. Oops. ASCII lowercase o. From string import ASCII lowercase. Test this out. Bingo, pass all of our cases, works great. Let's attempt. Bingo, works great. Everything checks out. Let's submit and take a look at the solutions that other people have put together. So interesting. This person is using a different property. But you see, we're also checking to see that it's an alphabetical letter, and that always goes at the end. People brought the text in like that and used that. So we have another person using the ASCII lowercase library, and they've done something very similar. This string of the letter +1, pretty good. Everyone is sort of doing the same thing. So yeah, this was another great kata. I think we have time for one more. So let's go ahead and get started with that. Difficulty 6. I don't know why it doesn't automatically load, but what's this? Array.diff. Your goal in this kata is to implement a difference function which subtracts one list from another and returns the result. If a value is present in B, all of its occurrences must be removed from the other. It should remove all values from list A which are present in B. Okay. So basically, I'm going to go through list B, and for every item in list B that I'm going over, I'm going to remove that item from list A as well. Interesting. So what we're going to do is for item in B, right? We're going over every item in B. If item in A, if that item is in there, and we're just going to do a.remove item. Okay, and then what should I return? It returns the result. Okay, so then we just have to return A, right? I just went through this really quickly. So we passed some of the cases. Let's see how many attempt cases we passed. Oh, we passed most of them, honestly. So let me go back to the test cases and let's work through this a little bit slower. I just did that really quickly. A was 1, 2, 2. B was 2. Expected 1, 1, 2. Oh. So basically, if I have a 2, it's only removing it once, not both times. Interesting. So we need to remove all instances of that number, not just once. So, in that case, we can do something in here where we just keep checking, or we have something to check. Actually, what we can do is we can do a for I in range of a.count an item. So every time that item appears, we're just going to go ahead and remove it. If I do that now, there we go. That gets rid of everything. We attempt this. There we go. Okay. So let me explain what I was doing here. Let me get a test case that we can take a look at. It was a 1, 2, 2 for A. And then I think B was 2. So let me bring my example in. Cool. Let me bring the indent down. Okay. So if you remember, our instructions were very helpful, actually. And they straight up just told us, if a value is in B, remove it from A. So 2 is in B. If I did this whole A minus B thing, I should hope to only have the 1s left, right? The 2s should both be removed. So I'm going to go through every item in B because, again, that's helping to guide me to remove it. And if that item is in A, so again, 2 is in A, then for every occurrence of that item, I'm going to go ahead and remove it. The reason I'm using a for loop is because a.remove only removes it once. So again, this 2 is in here twice. So when I was failing the test case, because if I only do a.remove, it only removes one of these. It doesn't remove the other one. So I need to have a for loop that keeps going based on the amount of times that item is there. So again, this will come up 2 times. So then this loop will run 2 times. And once it removes this one, then it'll be able to go and remove that one. And then, since I'm just removing off of A, what I return will just be the empty list with everything removed. So let's see. Again, this is a very simple example. Let's see what... oh, this is an even better example. Oh my goodness. I can't believe I didn't think of this. This is so much better than what we have. This is just a list comprehension that gets every item in A if that item is not in B. Very straightforward. It's just using your not and your in keywords to guide you. This is very similar to what I ended up doing. I guess this is sort of just also a lesson that you might be sort of instinctively drawn to just do something. Like I was just seriously just drawn to just that as the solution. But it's always good to keep an open mind because there might be a better solution. In this case, there certainly was a better solution, just using a simple list comprehension. But I think we've gained a level, and now we're at 6 KYU now. So level up is pretty awesome. But I think that's actually a good place to go ahead and call it for today's stream. So thank you guys for joining me. Hope you enjoyed today's stream, and I will see you guys in the next one.